Okay everyone, welcome to our fourth and final video for module 12.2, where we will be talking about set operators. Now, as we've discussed previously, we have three set theory operators: union, intersection, and difference, and none of these work with Microsoft Access. So these are exclusively for our larger DBMSs like Oracle or Microsoft SQL Server or MySQL. So today in this video, we're going to be talking about union, intersection, and difference. And a quick reminder here, in order to use any of our set theory operators, the two relations must be union compatible. And this means the relations have the same degree, which means the same number of attributes, and that these pairs of attributes are from the same domain. And union compatibility is a requirement for all of our set theory operations: union, intersection, and difference. And I'll give a demonstration of this in a little more depth in just a minute, but one way that this often happens is that the two relations that we are executing this set theory operation on are actually the outcomes of SQL queries that have been executed on the same relation. So in this case, relation R represents courses that are offered in the spring, and relation S represents courses that are offered in this Lindner building. So most likely, both of these relations were generated by running a SQL query that returned only tuples that match these criteria of being in the Lindner building or being offered in the spring. So we'll see what that looks like in just a moment. So for our union operation, and all of our set theory operators follow this same basic formula, where we have one query and another query, and then the word union in between those two queries. So we would start with something like select asterisk from R, and of course when we run that, we get all of the tuples that are in relation R right here. And we have our other query, select asterisk from S, and that is going to return all of the queries or all of the tuples in relation S. But now if we just put the word union in between these two SQL queries, now we see we get all of the tuples that are in relation R or that are in relation S. Now recall again, the tuples that are in both relations are not repeated in the resulting relation. Okay. The intersection is going to describe sections that are in both relations. In this case, sections that are offered in the fall and that are offered in the Lindner building. So it's a very similar format here, where we say select asterisk from R and select asterisk from S, and then between those two statements we just have the word intersect. And so now we see tuples that are in both relations. Now the difference operation is going to let us see tuples that are in one relation but not in the other relation. So in this case, where we're looking for relation R minus relation S, that's going to be sections that are offered in the fall in relation R but are not in the Lindner building. And the word we use in SQL for this is minus. So again, we have our first SQL query, select asterisk from R, minus our second SQL query, select asterisk from S, and that will show us any tuples that are in R but that are not in S. And then finally, we can do our difference in the other direction. If we want sections that are in the Lindner building but not in the fall, so that are in relation S but not in relation R, we could just reverse the order that we specify those. Now, one thing I need to point out here is that for the difference operation in Oracle, we use the word minus. Most other DBMSs use the word except to do the difference set theory operation. So just something to keep in mind, and anytime something doesn't work, again, like I mentioned in a previous video, Google is your friend to help try to figure things like that out. Now, I mentioned just a moment ago about this idea of union compatibility and how often union compatible relations are union compatible because they actually come from the same relation. And let me demonstrate what I mean by that. And we're going to go back to our course relation, or relation C, from our previous examples. So recall that the relation C has 12 tuples that describe courses. Courses have a course name, a course number, a credit, which is either U for undergraduate or G for graduate, and then the D code for the department that offers that course. So let's say we wanted to find all of our courses that are IS courses and also that are graduate courses. Okay, so one approach we could take to answering this question is to say select asterisk from C where course number like %IS %. So this is going to show us all of the courses that have IS anywhere in this course number, which in this case, it's these 4 courses right here. The second part of this question was what courses are graduate courses? So we could answer that with another SQL query, say select asterisk from C where credit equals G. So this is going to show us all of our graduate courses. And we see we have some that are IS, some that are ECE, some that are QA, some that are accounting. And what we could do, now notice we have 4 attributes here, course name, course number, credit, and D code. And in our other query, we have the same 4 attributes. So these 2 relations that are being generated by these SQL queries are union compatible. So if we wanted to find tuples that are both courses in the IS department and courses that are graduate courses, we would do the intersection of these 2 queries. So we have our first query, the word intersect, and then our second query. And when we run this, we get courses that are IS courses and are graduate courses. Now there's another way we could write this SQL query, of course, which would be to say select asterisk from C where course number like %IS %, and credit equals G. And when we run this query, we get the exact same output. Okay, so this is just 2 different approaches for answering this question. And now one more thing that I mentioned in the last video, but I forgot to demo for you guys, is that a full outer join is equivalent to the union of a left outer join and a right outer join. And so in the previous video, we had looked at the course that does not have a department and the department that does not have a course. And we said select asterisk from C. Let's start with an inner join. Inner join D on C dot decode equals D dot decode. And in this case, recall we have 12 courses and 6 departments. We only see 11 of our courses here because we have one course, Architectural History, that does not have a department. So in order to see all of our courses, we said we can use a left outer join instead of an inner join. And now when we run this, we see the 12th course, Architectural History, which does not have a department. And to see the department that doesn't have a course, we could do a right outer join. Now we lose our Architectural History course, but we do see the Philosophy department. And if we did a full outer join, we see both the Architectural History course and the Philosophy department. So the other option, instead of doing a full outer join, is if we did a right outer join. followed by a left outer join, and then did the union of these two relations. The first one that results from this query, and the second relation that results from this query. So when we execute this code, we see we get the same 13 tuples that we got from our full outer join. So again, there's almost always multiple ways to write a SQL query to answer a question. So you got to have a lot of good tools in your tool belt. Now to wrap up Module 12.2, we have a virtual in-class exercise. So go to this URL here, and you're going to find several SQL queries. Some of these SQL queries are correct, and some of these SQL queries have an error. So if you think there is an error in the SQL query, your job is to write the query correctly, and it'll just be one error per query. Okay, so you don't have to rewrite a lot of stuff. It's just one error per query. Or if the query is correct, just write the word correct as your response. So you'll have until Monday night at midnight to complete this virtual in-class exercise, and make sure you do the entire thing because I'm trying something a little bit different with this one, and there's a little surprise for you at the end. So with that, go do the virtual in-class exercise. You guys stay home, stay safe, wash your hands, don't touch your face, and go forth and do great things.